Now let us look at the manufacturing of the shaft. Go to new manufacturing and take this shaft underscore manufacturing. Okay, select this and click OK. Now import the shaft. Okay, so put the shaft in its default direction. Click on tick. Now let's build the work material. Click on this, then cylinder. Then to change the orientation, click on options. Rotate it about y axis by 90 degrees and change the diameter to 130. Then then select the tick mark. Now introduce a new coordinate system. Click on this. Then select this plane. This plane and this plane. Then click OK. Not we need to make sure that Z is pointing outside. So go to orientation, determine Z, click OK. Now we have a new coordinate system in place. Now let's start building our profile for area turning. So go and click this button, then select sketch, select ACS1, then sketch again, then sketch. Now select your references. Then using the line tool, draw your first profile. Click on tick mark. Once again tick. Now go to steps, operation, NC machine, press this, then lathe, click OK. Machine 0, select ACS1, click OK. Now once again go to steps, area turning, leave it as it is, click done. Once again apply, then OK. Give cut speed as 20, step depth as 1, then spindle speed as 1000, and click on OK. Insert tool profile, so select this and give positive X and positive X here, then click OK. Once again OK and play the path, screen play, and click on play. Close it. The path looks correct. Then done sequence. Now let us use the grooving tool for a different profile. So let us first create a new profile. Click on this again, then sketch, ACS1, then sketch again. Select your references. Click OK. Then draw your lines. Start from here. Then use the use command. Make sure this particular sequence is being followed. Then click on line and complete the profile. Now click on tick mark. Once again tick. Now go to steps, groove turning, done. Click apply. OK. Cut speed as 20. Step over as 0.5. Clearance distance as 1. Spindle speed as 1000. Click OK. Insert. Select this profile. give positive X and positive X. Click this to view the profile and then use tick mark. Okay. Play path, screen play, play. Click on close. Here also the tool path looks correct. Then done sequence. Now let's create one last profile to create a groove in this area. So go to tool, turn profile, sketch, ACS1 sketch. Then once again select your references, this line, this line, this line and this line. Close the references, use the line tool and draw this profile. Click on the tick mark once again. Now steps, groove turning, leave all this as it is, done. 20, step over 0.5, clearance distance 1, spindle speed as 1000. Click OK. Insert, tool profile, positive X and positive X. Looks fine, so click tick, OK. Then play path, screen play. So let's click on play. Once again the tool path looks correct. So let's close it. Done sequence. So we are done machining the shaft on a lathe machine. So let's save the work. Save. Okay. Now let us look all the three operations in one go. So select this, hold Control and select these two. Right click, play path. You can use wireframe to see the tool path and click on play. As you can see, it was completely correct. There was no tool path overlapping with the path, so it looks good. Now let us look at the next part, that is our cap. So go and create a new manufacturing, use default cap underscore manufacturing. Okay. Insert it, cap, open, use default, click on tick mark. Now let us build the workpiece material around it. Options, rotate it about 90 degrees. Now this rotates by 90 degrees. Give it diameter as 130, total length as 20. Click on tick mark. Now we just need to remove this particular portion from the workpiece to get this part. So let us create a profile to remove it. So, and before that we need to give a new coordinate system. So click on this, then the surface, and the surface. Click OK. You should have Z pointing outwards. So edit definition, orientation to determine Z. Okay. Then let us go to profile, sketch, select this coordinate system and click on sketch again. Now select your references the wireframe here. Select this line, this line, this line, and click on OK, close, and tick mark. And then use the line tool to draw this profile, and then click the tick mark and make sure this arrow is pointing downwards. Click OK. Then to start with, first we need to make a hole here with a drill bit to do the boring operation. So let us go to steps, operation, NC machine is lathe here, click OK. Machine 0 will be this coordinate system, then click on OK. Now go to steps, drilling, standard drilling, done. Make this 180 degrees, click apply and then click on OK. Give cut speed as 20, clear distance as 2, spindle speed as 1000. Click OK and let us select this plane, here it is, OK. Then this will be our axis, and here select this and give 10. Click OK. Display path, screen play. Yes, we just made a hole with a diameter of 18. Close. Done sequence. Now next let us go to steps, area turning, done, apply, OK. Cut speed, give it as 20, step depth as 0.5, spindle speed as 1000, click OK. Insert the tool path as this for negative x and negative x. So this part will be machined out. Click OK. And OK, let's play path, screen play. So the tool is oriented like this. We should rotate it by 90 degrees. So let us go back to sequence setup, tool, parameters, done. And also this length must be less, so let us make it as 10 and this as 15. Click and mouse radius will give us 0.1. Apply, yes, OK, and rotate it by 90 degrees. Let us make it 0, OK. Display path, screen play, yes, now it looks fine. So we machined out this particular part from the cap. So we have a cap now, it's ready. Close, done sequence, and save it. Now let us give milling operations to our support. So let us place our support. Open, default, OK, workpiece material, OK. Then new coordinate system, select this surface, this line and this line, make sure that this pointing outwards. So looks fine now, OK. After that go to mill volume and go to sketch, select the surface, sketch, use the references, close, and take a rectangle, then come out of it, then select this and now extrude the part inwards into the material by 20 units. Then click on tick mark and then click on this option called trim. Select the part, then click OK. Now go to steps, operation, NC machine, milling, OK. Machine 0, the new coordinate system, surface, leave the value as 20. Okay, then click on apply. Okay, now go to this particular option called as volume rough. Click on it, then give all these options: tool, parameters, coordinate system and volume. Click done. Look, these parameters look fine here, so click apply. Okay, recutting feed 20, step depth as 2, step over as 2, clear distance as 3, spindle press 1000. Click OK. Now select the coordinate system, so we'll give this. Click on OK, and now select this particular hole. Now go to wireframe and play the path. As you can see, using a miller we created a hole here. Close it, done sequence, and save the file. Now let us look at how do we mill the base of the pulley. So create a new file, manufacturing, base, manufacturing. Okay, click on OK. Import the part, base, open, select default, click OK. Build the workpiece material, click on tick mark, create a new coordinate axis system, select this line and this line, make sure Z is pointing upwards. Click OK, and now go to mill volume, select the top, now select the top volume, go and click on sketch, select the top volume, and click on sketch again. Now use the references and this, close, draw your rectangle completely, click on tick, extrude the part into the material and give it as 50, click on tick mark and then use the trim option, select the part, click tick. Now let's go and create an operation, steps, operation, milling, okay, machine 0, our coordinate system, retract surface, give value as 20, okay, apply, and then once again, okay. Now go to volume rough, give tool, parameters, coordinate system and volume, click done, click apply, and then click OK. You cut feed as 20, step depth as 2, step over as 2, and flame resistance as 1, spindle spring 1000, click OK. Now select the coordinate system once again, and then select these holes. Okay. Click OK, and now select these holes, and then use wireframe and then play path, screenplay, and hit on play. As you can see, both these pockets have been moved. So click on close, done sequence, and save it. Now we have seen the operation for all the parts of our pulley assembly. Now let us see how do we generate CL data for an operation. So first select the operation, go to edit, CL data, output, then operation, select OP010, then select file, click on LCD also, and click on done. Let us save it in the folder with the same name op010. Click OK and click on done, and select any one of these. For now, click on this, close, done output. Now we have generated a CL file, so save it, click OK, and let us view file that we have just seen. It is saved here, so let us open with notepad so as we can see the code. So as you can see, we have the code here, and we can follow the same steps for all other operations also and generate the CL file. Thank you.